Thanks for joining us today. This webinar is going to focus on the fundamentals of cryopreservation, and we're joined by Erica Waller, all the way from Boston, US, is it, Erica? Who's the product manager for cryogenic storage and automation at Azenta Life Sciences. Azenta are one of our exclusive supply partners in the UK, and you might know them from their well-known brands FluidX, Fortitude, and of course the Azenta Cryogenic range, which we're going to talk about today. And we're really lucky to have Erica with us today. She's a real expert in her field. Following her graduation from MIT in Boston in 2017, Erica actually worked on designing these systems. So your role was an engineer at Brooks Automation previously, before Life Sciences. So Erica's worked to actually design and build these systems. I'm just going to mute everybody. So today we've got an hour for this seminar. So we anticipate the presentation will take around 40 to 45 minutes, which should leave around 15 minutes for questions. However, Erica's going to be on presentation mode, so if you've got any burning questions in the meantime, please use the either raise your hand function or bob your question in the chat. I'm going to be manning the chat, and I can feed that back to Erica. But there is scheduled time. There is scheduled time for questions at the end. What I'm going to do is mute everybody throughout. But as I said, if you do have questions, please raise your hand or use the chat. Just a note as well, we will be recording this session for anybody that couldn't join us today. And of course, you will all have access to the recording as well. But just to let you know that the session is being recorded. And then finally, from me, if you're at Lab Innovations next week, it takes place at the NEC in Birmingham at the 29th to 30th of October. Both SLS and Azenta will be on the SLS Pavilion, which is stand K80 there. So if you've got any questions or would like to talk to the Azenta team or the SLS team in person, we will be there next week, and hopefully we'll get to see a few of your faces. But that's enough from me. So I'll pass over to you, Erica.
Yeah, sure thing. Thank you so much for the introduction. All right, just gonna get this PowerPoint up. Okay, so hello everybody. I'm going to be talking to you today about cryopreservation and storage of samples at cryo temperatures. So just to get us started, who is Azenta? They make me do this. It's a corporate requirement. Apologies. So Azenta is a company that is made of all the best-in-class brands, many of which you may be familiar with here. All of these different pieces of the sample management workflow come together under the Azenta banner. And our purpose is to help customers like you innovate faster and get to breakthroughs faster. So these are all different little companies that have come together to form this one entity. We have a lot of different workflows that we work on. We are two operating companies, one on the genomic side, so you may be familiar with GeneWiz, who provide different multi-omics and synthesis solutions. And then the sample management solutions side of the house, which is where I live. This is focused on everything about handling a sample, from the container that it's in at the start to the different ways you can move it through your workflow, instruments, even instruments like storage units, and then sample prep and informatics as well to help you manage the data trail formed by all of that. So as we start in on this presentation, what I'd like you to keep in mind is just for yourselves, what is your biggest challenge with cryo storage and management of that cold chain? To just kind of keep that tucked away. And we're going to go through some key surprises that we found. So when Azenta started developing cryo products, we started with our customers and we started with data. So this is the story of that data and what we learned working with our early customers to better understand what the challenges are in sample management and how we could help address them. So what is cryostorage? It's the storage of biological materials below -135 C. Some people even consider it below -80, but for our purposes, we're working in the -135 or colder range. So we're talking about liquid nitrogen. Typically, it's going to be cells and tissues. It could be stem cells. It could be cell therapies, either autologous or allogeneic. All of that's fair game. Anything that may not be stable above that critical temperature, and anything that you want to be the same when you thaw it as it was when it was frozen for the long term. So the beauty of cryo storage is once you get something below that critical temperature, biological activity ceases and it remains stable pretty much indefinitely. You could cryopreserve a steak, thaw it out 20 years later, and it would be like you had just picked it up from the supermarket. So the critical part of all of this, though, is that once the sample gets frozen, it has to stay frozen. So if the sample is brought above that critical temperature, you're going to have a reduction in your post-thaw viability and recovery. And the more that this happens, the more damage that accumulates through the life of a sample. So here's some data that we worked on with one of our customers. These were mesenchymal stem cells, and we compared their different characteristics before and after storage in cryo tanks. So what we were looking at is what happens if you cycle these samples in and out, kind of like what you would expect in a normal working biorepository, where people are pulling things out of racks and they're looking for them. They sit out for a little bit while you do what you need to do. You put it back away. 20 exposures to -110°C over 3 months. And what we found was a very substantial decrease in viability and recovery. So this is before and this is the after. It's pretty major. The recovery especially was really, really poor. A little reduction even just with the control, but the cycling was really bad for those samples. So we kind of started here to say, how bad is it? And when does it happen? So this is sort of a simplified workflow of what you might see in any sort of biobanking situation. You've got samples coming in on shippers, they go into a freezer, somebody takes them in and out of the freezer looking for the box that they want with the samples they want inside of it. They'll take that to the lab and work on them, maybe put them back in storage when they're done and then ship them off somewhere else. All of this is fairly normal. So every one of these arrows is a point where samples can be warmed up, because they're not being held in some kind of storage environment. Each one of these is an opportunity for that accumulation of damage. So to start, we're going to focus on the movement between in and out of the freezer. How fast does a sample warm? So how much time do you realistically have to get something in and out? It's a more complicated question than people might think. It has a lot of different variables that affect it, but one of the things that we were first curious about is what happens if you put these tubes as you pull them out into dry ice. That's a pretty common way to manage them. So we wanted to understand how much time do you have before they're being damaged. And what we found is that if you put the tube on the table, just in ambient, nothing, no protection at all, it takes about 55 seconds for it to cross the critical temperature. If you put that same tube on dry ice, it happens in half the time. So the smaller the tube, the faster it happens. Of course, you have less volume. And at the end of the day, that means you've got 1 minute or less to get that sample and put it somewhere safe and return the rest of your samples to storage. So you don't have a whole lot of time here, much less time than you might think. And dry ice makes it worse. So looking at the dry ice itself, because we were kind of surprised by that result, we wanted to understand more about how this could be happening. So this is a more detailed graph showing the difference between a tube held at room temperature, that's our blue line, and a tube held in dry ice, just buried in the dry ice, that's our green line. And you'll see the dry ice sample warms up to -80 extremely quickly and then holds there, because samples on dry ice are meant to be at -80. That's the temperature that dry ice is sublimating at. So that's what it's very good at holding. It's not appropriate for a sample that came out of a cryo environment at -190. The difference in temperature between those two is 110 degrees Celsius, which is equivalent to an oven at 230 Fahrenheit. That's a pretty substantial change for this sample to go through. And this gap here is the difference in time it takes to cross that critical temperature. So you're getting there with dry ice much faster than you would be even just on a table. So cold in this case isn't cold enough. Just because it's frosty doesn't mean that it's safe. So then going back to our workflow, we now know how fast a single tube is going to warm up being carried around between the different stations. But what about all the other samples that are in that freezer rack or in the box that you're targeting? What happens to them? So we tested it. What we found is that warming actually continues after the samples return to the freezer. So you would kind of logically think the maximum temperature the samples are going to reach is the temperature they're at when you put them back into storage. But that's not true. There's actually some elasticity to it. So it takes another 2.5 minutes after 30 seconds of exposure before the maximum temperature is reached. There's a lag there. And that lag is something that you have to be paying attention to, because 30 seconds doesn't sound like it would be a problem, but depending on your starting temperature, it very much could be. Samples exposed for just over 2 minutes are reaching the critical temperature by about 4.5 minutes. So that's kind of your maximum point. Your safe exposure time is going to vary. It really depends on what kind of samples you have, how much thermal mass do they have, how many other samples are around them. But if you need a rule of thumb, 1 to 2 minutes maximum is a pretty good rule of thumb to start. So then what happens to the other samples in that freezer rack that came along for the ride? They weren't the box you were targeting. There are some other samples that were there. How long does it take them to return to that starting temperature? About 3 hours. In about 1 hour, you're going to recover 75% of the original temperature, but that remaining 25% takes another 2 hours to fully reach. So every time that you remove a rack from the freezer, everything in that freezer rack is subjected to this thermal penalty. Your starting temperature will increase. And as your starting temperature increases, the window you have before you're crossing the critical temperature gets smaller and smaller. So it's really important to be paying attention to not just how long you are exposing the rack at this moment, but how long has it been exposed in the recent past? Has it had enough time to come back down to a safe temperature before you pull it again? So all of this comes together for some best practices focusing on sample integrity. If the sample started in LN2, keep it in LN2. Dry ice is not going to be cold enough for a sample that's supposed to be in that LN2 environment. Pay attention to the opportunities for transient warming. So anytime a sample is removed from the storage environment, and that also includes the non-targeted innocent samples that came along for the ride. You need to minimize your exposure time for all samples during handling. 1 to 2 minutes is the rule of thumb. And remember that that temperature will continue to rise after returning to storage. So just because it was just below the critical temperature when you put it back doesn't mean it's going to stay that way. It's going to cross that line over the next couple minutes as it returns back down to temp. And account for that thermal penalty. So it's a good idea to try to organize the collection to make sure that each freezer rack has enough time between accesses to cool back down to the starting temperature so that you have the maximum window possible to retrieve your samples and keep everything safe. So this might be a common statement you've heard. This is something that we have heard from a lot of our customers. I don't want other teams touching my samples because I don't trust them to manage them the way that I would. So we should each have our own separate freezers, and that way I can ensure that my samples are kept at the right temperatures, they're handled minimally, they're maintaining their integrity. That's the best way to make sure of it, is that I need to control that. It needs to be in my lab with my freezer that only I access. So at the end of the day, when you're storing in cryogenic temperatures, there are 3 things that you're trying to do. You want to know what you have, you want to know where it is, and you want to make sure you limit the access to those materials to only the people who are supposed to have access when they're supposed to have it. So solving that problem, one way to do it is everybody gets their own freezer. If everybody has their own freezer, you know what you have because you put it there. You know where it is because you put it there. And you know that nobody but you is touching it. So you're sure that the access is only to yourself. but there are hidden costs for doing it. So behind door number 1, we have material cost. So every freezer that is purchased, that's a capital expense that has to be done. There's LN2 supply that has to be accounted for. And there's also typically validations that must be done on each unit in order to maintain accreditations and various sort of paperwork there that you have to do. So that's happening for every freezer that you buy. There's also a personnel cost. So if everybody is going to manage your cryo storage, then everybody has to be trained on how to do it appropriately and safely. There's documentation that is required as part of that. And there's ongoing maintenance that must be done. So somebody has to be going around to all of those freezers and making sure their liquid levels where it's supposed to be. There's no alarms or errors with any of the freezers. Everything is as it should be. And that has a real cost to it. And finally, there's the opportunity cost, which I think is one of the easiest ones to ignore, but is one of the most important. The floor space. So every freezer that you have is a section in your lab that you don't have a different instrument that could be doing something more for you. You often will also see duplicated samples. So if each team is maintaining their own personal collection and they're not sharing those collections between them, maybe you have too many of a certain cell type in team A and team B needs it. They don't know that they can go ask team A, hey, could I have some of those so I don't have to buy more? They just buy them. And then you're duplicating the work as well, duplicating the work of maintaining all of it and duplicating the work of making sure that everything is in compliance and safe. And all of those costs really do add up quite a lot. So this is shamelessly stolen from the great work of Kathy Shea and her team over on the better sample management side of Azenta. They've spent a lot of time going into different repositories and storage environments, helping various people understand what is in their collection and how can they better manage it. So what they have found across the entire sort of storage range, not just cryo, but everything, about 16 to 22% of the research lab space is used for freezers and refrigerators. Those freezers are often only filled to 50% of their capacity. And of that 50% capacity, less than 10% of the items that are stored there are actually even touched on any sort of regular basis. When they look at them, less than 50% of the items in those freezers are even considered usable. So they either aren't labeled, so nobody knows what's in this tube, or they might have some labeling on them, but they're missing other critical documentation like consent. Could be any and all of the above. And that means that researchers are wasting about 2 hours per week on that inefficient inventory management, trying to find what they need, trying to find a usable version of what they need, and trying to make sure they keep their paperwork straight as they do this. So less than 40% of labs have the tools that they need to do that optimal inventory management. So when you start to think about it, you can gain 10% of your lab space back by reducing your freezers, because if they're only filled to 50% capacity, they're not being very efficient, right? That's a pretty easy win. And researchers can gain over 100 hours per year and have more space for their research by optimizing that inventory management. So going back to our cryo storage challenges, what do I have? Where is it? How do I make sure that only the right people are touching it when they're supposed to? Another way to solve that problem, or those problems, is an inventory management system and or the addition of automation as appropriate. So very commonly what we find, people have multiple inventory systems, they have limited visibility, and they have, as a result, poor utilization of samples and other materials. So if everybody has their own individual Excel spreadsheet, none of those spreadsheets are talking to each other. So you're not able to look across the whole breadth of the collection and understand what you truly have. Moving that to one compliant informatics solution allows that visibility so you can better manage the samples as well as the data associated with them. It's all in one place. It's also very common to see an aging freezer infrastructure, and the older those freezers get, the more they have risk of failure. So the better way forward is to optimize to your newer, more reliable freezers that you already have and get rid of the older ones that are only half full anyway. Consolidate into the newest models you've got so that you can reduce the CapEx and also increase the total lifespan of your fleet. There's also a lot of valuable real estate that's used for archived collections with who knows what. Some of these samples are 50 years old or older, and nobody knows what they even are anymore. Reducing samples to a true sample inventory can help you reduce that freezer footprint. So sometimes the right thing to do is to say, look, we don't know what this is. We can't use it. Let's stop storing it. It's time to let it go. And then you've got the scientists wasting their time. They're trying to find samples. They're buying new ones when they already have it. If you can have this compliant informatics solution and manage that data, then that's not necessary anymore. And the scientists can spend their time doing the research that they're there to do. So it's less of their time on that inventory management piece. And then the sample management processes are usually pretty all over the map. Having consistent SOPs, that's the way forward there. So if you don't need to have everybody in their own freezer and you have a smaller fleet, you have less people that need to be trained on how to manage it, you can have more consistent SOPs, have better sample integrity, and more time for your researchers to do the research they're there to do. So that brings us, of course, to how does Azenta help with all of this? So when we develop these products, we develop them based on that data and to solve some of those challenges that we just went through. So Azenta offers a cryo portfolio of manual access high efficiency freezers, as well as automated cryo systems and some cryo instruments to help with the transition in and out of storage and maintaining that cold chain. Our high efficiency freezers are all here for you. They are designed and built in Springfield, Massachusetts. So we have a nice little facility there. And these were all developed based on direct user feedback working in and out of manual access tanks. So the main changes that were made for usability, the ergonomics. So a lot of work was done on these steps and this bar to make sure that we're reducing the liftover height. We've added this nice flat top workspace so that you actually have somewhere to put the rack that's not on the floor, which is how most people usually go and get their samples. They just put the freezer rack right on the floor and dig around. Here you have a workspace that's right there for you. They also all come with an LED and auto fog clear, and that LED is actually inside the cryogenic environment so that when you open that lid, light turns on, little puff of air, and you can fully see everything that's inside that freezer. You don't have to sort through the fog and wait for it to clear. It's just visible immediately. We also get better capacity. So by adjusting the diameters of these tanks to not what the tank manufacturer wants, but what makes sense for the samples going inside of it, we were able to get 10 to 30% more samples in basically the same footprint. That also reduces your LN2 usage per sample by doing it that way. And they all come with connectivity. So text and email alerts by default. They all have a touch screen with Wi-Fi and LAN hookup, so depending on how you'd want to do it. And they have an optional redundant remote monitoring portal. So part of how we got that increased capacity was by taking a look at the rack design. So I think everybody who's worked in freezers before is very familiar with the square racks on the side here. This is pretty much the industry standard. We do offer those. Some people just really prefer it. That's totally fine. We've got them. But we also worked with our rack manufacturer to develop a slim rack design that reduces the number of racks that are exposed when you pull it. And it also substantially reduces the weight that has to be pulled in and out of the freezer. So the weight of one of these square racks is actually pretty heavy, especially when you fill it with samples. And that repetitive stress of pulling it in and out really, it hurts your shoulders. It's just not ideal. So by reducing the number of boxes that are held, it's better for your sample integrity, it's better for your capacity, and it's better for the ergonomics for your operators. So it's a 60% reduction in the weight that is lifted compared to the equivalent square rack. And now our monitoring portal. So this is actually one of my favorite parts of our manual freezer offering is we have this really cool portal. It gives you real-time performance data in the cloud. You can get into it from the web. You can get into it. There's an app, iOS or Android. It allows you to observe freezer performance over time and troubleshoot issues remotely. It gives you the full event log as well as regular consistent readings, which can provide context for an alarm state. So think with me of a situation, say it's, Friday night, you've gone home for the weekend, you're about to have a really nice dinner with your family, and you get a notification from your freezer that it has a high level alarm. What do you do? Well, without the monitoring portal, you're going to have to go back into the office and figure out what's wrong with this freezer. You're going to have to go physically get there and take a look at it, and that's going to ruin your Friday night. With the monitoring portal, you can pull it up and actually take a look at what's going on. So we can give you all of the readings from the freezer controller, and you can take a look and see, oh, hey, the level's been behaving kind of strangely. I think there might be something wrong with the level sensor. The temperature probes are telling me that everything's okay. I think this can wait another day, or no, this is really important. I need to go right away. But at least you actually have the data to back up that decision. It's not an automatic has to go in. It's a choice that you get to make with context and data to help you make the right decision. And this is just sort of what that looks like. So it's giving you your temperatures, your usage, your level, all of that information. And that is one of our freezers, actually. So our automated cryo storage portfolio, we have 3 sizes, the Pico, the Deca, and the Terra. And these are built on those same freezers, just adding additional automation components to further enhance the sample management workflow. So the workflow for an automated unit like one of these, you can walk up to the machine, log in with your own identifier. So everybody gets their own ID and their own account, so you know who's doing what when. You can scan the ID or just type it in, whichever, load in the file, however you would like to do it, to tell the system which sample you would like to retrieve or which samples. You click a few buttons and the system goes and gets it for you. So you have all your data at a glance. There's a common software across all of them. So if you can use a Pico, you can use a Terra. It is the exact same software and the exact same automation principles underneath the hood. They also have that support for cloud-based monitoring as well as our high efficiency freezers do. And once you have decided what samples you want, the system will go retrieve them for you, and you open the door and retrieve the box. That's all you have to do. So nobody's lifting freezer racks in and out. Nobody's digging around in the LN2 environment. All you have to do is touch a box. And this is scalable as your collections grow. So if you start with a small one and then eventually you work your way up, you can get bigger ones, but it's the same system across the board. No matter what, you don't need to retrain. And typically the way that we suggest is that you place that box inside a cryopod, so we keep them handy nearby. And that gives you a safe cryo environment to be picking your tubes in to make sure that you don't have a transient warming event there. It's also flexible for vials, cryo bags, tubes. If it fits in a cryo box footprint, we can probably put it in this system. So it has a lot of flexibility for the different container types you may be working with. And how do we protect sample integrity? This goes back to all that data that we did. Why did we take this data? So we can make sure that the system we designed was going to make sure those samples are safe. So it starts with an insulated tower. This helps prevent convection impacts to the samples while they're out of storage. So no matter what you do, the rack's got to come out. It can't be helped, but we can do things to protect that rack and protect the samples inside of it to make sure that they warm as little as possible. The software is also smart enough that if you don't touch the screen, you just don't interact with the machine at all, after 30 seconds of inaction, it puts the samples back in the freezer. You can resume the order later when you're ready. But what this does is it eliminates that human element. How long was the rack exposed for? You always know. And if it's getting exposed for too long, the system will act to protect those samples. There's also onboard inventory management just built into the system, so you can order your samples based on a unique ID rather than remembering the location, which is a real game changer because if somebody moves your sample around, it doesn't matter where it is. The CryoArc system knows exactly where it is. All you have to do is say, I would like tube ID 1, 2, 3, 4, 5, and the system will go get it for you. It also records all of the user actions and sample details, so you have a full audit trail for the lifetime of the system. There's never a question about how long was this sample exposed. You can pull up a graph and see it. And that is very helpful in more regulated environments with 21 CFR Part 11, for instance. So there are some additional software licenses that we offer depending on your use cases and what you need. The web API is a very common one that allows you to connect the CryoArc system to external LIMS if you'd like to do that, or other instruments. Library management is another really cool one. So this is our solution to everybody should have their own freezer so I can make sure that nobody touches my stuff. With library management, you can actually restrict individual users to a single box if you want to do that. And as long as you have given them access to only that one box, that's all they can touch. They can't even see anybody else's stuff. So that allows you to use this one single CryoArc system as a shared resource between other groups and not have to worry about Group A stealing Group B's samples. It can't happen. The system won't allow it. The reports module gives additional compliance for 21 CFR Part 11 requirements. So it's just more audit related information in a convenient PDF package. And then alerts adds text or email information about the system that you can configure. We also do connect with our own in-house LIMS. So we have a built-in connection with Freezer Pro, which is very useful when you're trying to connect your manual storage tanks with your automated storage tanks, especially if you have multiple automated storage tanks. Freezer Pro can communicate between all of those things and help you keep track of all of your samples, no matter what freezer they're stored in. It knows where they are and makes it much easier for your sample collection to be monitored and maintained. So what do we do about getting samples out of the freezer to the bench? We developed the cryopod for exactly this purpose, and the cryopod filling station to put liquid nitrogen into the cryopod in a simple and safe way. So there are two cryopods. There's one designed for cryoboxes, and there's one with a slightly larger basket designed for cassettes. These can hold one cryobox, two SBS format racks side by side, or a small stack of cassettes, depending on what samples you have. And they are designed for intracampus transportation of samples below -150. So when you fill a cryopod with liquid nitrogen, you're going to have at least 3 hours, maybe more, colder than -150. So it's a minimum 3-hour hold time for any samples that are stored inside that cryopod. The samples remain in the vapor phase, so they're not in any contact with liquid nitrogen. The basket is what they're sitting in, the liquid's below, so there's no touching. And the cryopod also includes downloadable temperature logs. So you can take your temperature records from your CryoArc system, take your temperature records from your cryopod, and have a full picture of the entire event for the samples that came in and out of storage. So you know what temperature they were at when they left the CryoArc, you know what temperature they were at while they were in the cryopod, all the way up to when you thaw them to go use them. And the cryopod filling station, you can think of it like a Keurig for your cryopod. It allows a single button, hands-free filling of a cryopod with liquid nitrogen. It's consistent. No operator needs to contact LN2 at all. It's faster, fills in about 5 to 7 minutes, depending on your LN2 supply. And the other cool thing it does is it maintains the fill level throughout the day. So the cryopod is always ready with that 3 hours hold time exactly when you need it. So you can fill a cryopod in the morning to go take some samples, put another one in the filling station to fill it, and leave it there. And throughout the day, the filling station will be monitoring the liquid level in that cryopod. And when it sees it gets a little low, it'll top it up. So that as soon as the next person needs one, there's already a charged cryopod ready to go. They don't have to wait at all. So what does this all look like pulling it all together? The Azenta cold chain workflow looks a little something like this. You've got your CryoArc automation and or your Azenta high efficiency freezers paired with very strong SOPs to protect sample integrity and provide you with best-in-class options to manage your collection. Those items are connected to Freezer Pro and the Cryo Monitoring Portal to increase your efficiency in your inventory management across all of that equipment and also to improve your equipment maintenance with that monitoring portal. And then you've got the cryopod and filling station working to keep those samples secure during transportation in and out of the storage environment to ensure that no matter where your sample is, the integrity remains intact. And that is what I have. So let me see if I can see you all. I might have to stop sharing for this. All right. Are there any questions? That was a lot of information to throw at you. So I'm not sure. Katie, did we have any in the chat as we were going along?
I didn't see any in the chat.
Right. Well,
No.
please don't. Oh, go ahead.
I was going to say what we will do is we'll share Erica's details with you all as well. So if you've got any questions following this webinar that possibly you don't want to ask here and now, you will have option to contact Erica directly. Oh, Amy, do you have a question?
Oh, there's one from Katie first.
So Katie's just put, Erica, out of interest, what's the price range for these kind of freezers?
So I'm going to assume you're talking about the automated freezers, because that's usually, I think most people have a pretty good idea where the high efficiency ones sit. So the automated freezers are around 120 to about 250K for the system. That's about where they're at. Obviously, with more add-ons, they could be more expensive. It also depends on your validation needs, that kind of thing. But that's a pretty good rough window where they fall.
We haven't put any prices on the SLS website, Katie, just because they're, as Erica said, very modular, depending on the racking, the servicing, and the validation that you go for. So, but if you are interested in a specific quotation, please reach out and SLS can provide that for you.
Yeah, absolutely.
Amy, did you have a question?
Yeah, just my quick question, Erica. So if you're working manually with your samples at the moment, storing your samples, what would you suggest would be the first key steps to consider for initial movement into automation?
Yeah, so it's always a really challenging topic to go from a manual workflow to an automated one. It's a big leap. Typically, the first steps are assessing what your collection even is. So what container types are you working in? Can you try to consolidate or standardize those? Automation-friendly consumables are obviously a great place to start if it's possible for you to move into something automation-friendly, such as our FluidX line. That's great. It's already barcoded. It makes it simpler. But there's also legacy collections that just aren't realistic to move. We understand that. So getting a list of what's going to be in there, making sure that it's the stuff you want to be in there. Then it's a matter of getting the tank set up, getting it where you want it to be, training your people, and then migrating the samples. So during initial sample migration, you can just drop in, if you've got it in a CSV format, you can upload that whole thing and load in the entire system with the data you've already got, and then start using the system to be tracking that going forward. So after the initial load in, it's much simpler after that. But I would say it definitely starts with what consumables do you even have to put in here, and making sure that you've got consolidated as much as possible. I believe we also have a guide on exactly this topic. So if you're interested in a little more detail on it, we can provide that to you.
That's perfect. Thank you.
Another question from Emma. Off you go, Emma.
Yeah, sorry, thank you so much for that, Erica. That was really informative. Just in terms of the CryoArc and the CryoPod systems, how would you be able to integrate these with kind of existing inventory or informatics systems to, kind of ensure that full traceability and compliance?
Yeah, sure. So the CryoArc systems do have the Web API module. So if you've got an existing LIMS and you would like to integrate your CryoArcs into that, you're going to need that API module. But with that module, it is a RESTful API interface. So you'll have to forgive me because I'm not a computer scientist. I just married one. So I know just enough to be dangerous. But with that API module, it comes with a full wiki and a virtual machine test environment for you. So you can set up the connections between the data fields. And once that linkage has been done, you can drive everything out of your LIMS. So you can order your samples in your LIMS, send the order to the CryoArc, and then you just have to walk up and hit, I'm here, give me what I asked for. So that side of it is fairly simple. You just need a little bit of app development to make the connection. For the cryopods, those are the temperature logs are a CSV file when you download them. So you should be able to upload that into basically anything that you would want. You can usually, I think LIMS systems do have the ability to hold extra files like that. So you can continue to add that into your LIMS as just a saved file to show the continuation of the cold chain. So they're both pretty friendly to external systems and by design.
Brilliant. Thank you so much.
Thanks, Emma. If there's no more questions, we can wrap up there. Just as a reminder, we will be at Lab Innovations. Oh, sorry. Last question. Next question, Erica. If we ship cells on dry ice and they arrive in viable condition, why is it risky to put them on dry ice for a few minutes if you need to shuffle a few cryovials?
So it really depends on the sample type. Some are more sensitive to fluctuations than others. So the data that we did was on mesenchymal stem cells. So for those ones, fluctuating in and out of cryo was really not good for them. You can do your own testing to make the decision for your own specific sample type and use case. But what we did find is that dry ice is very good at holding -80. So if your sample is okay at -80, then it's okay. But if your sample is not okay at -80, all you're doing is basically putting a hand dryer on your sample until it hits -80 and then holding it there. So it's something that you can definitely test, and it really depends on your sample types, but some of them are too sensitive to bear that kind of change in temperature.
Thanks, Erica. If there's no more questions, then we can wrap up there. And just a reminder, we will be at Lab Innovations, both Azenta and SLS, on the SLS Pavilion next week at the NEC. So hopefully we'll see a few of your faces there. We will follow up as well with the recording of this webinar and possibly the guide that Erica just mentioned in her contact details should you have any questions following this webinar. Thank you, Erica, for all that information. I thought that was great.
Thank you all so much for having me.
Thank you. Thanks, everybody.
All right. Goodbye.